Welcome to our first H2 minute experiment video. In this video, I will be demonstrating the information we discussed in episodes 7 and 8. I will go watch those videos now if you haven't already done so, or if you just need a refresher. Here I have different cups of bottled waters and some other drinks. Our first experiment will be to check the pH of these beverages with these pH drops. Let's bring our pH scale back so we can see what the pH is based on the color. Now, when testing pH, you should always ask the question, why is the pH of this liquid the way it is? The bottled water I used in this cup is Aquafina, and it tested out acidic. The reason this and many other bottled waters are mildly acidic is because they are reverse osmosis. This means that a vast majority of the minerals have been taken out of the water. When water is exposed to air, carbon dioxide from the air will dissolve into the water, forming carbonic acid, which makes it slightly acidic. Now, it doesn't mean that carbon dioxide doesn't get into any of the waters higher in pH. It just means because of the lack of alkali minerals in these waters, there's nothing to balance out the pH. This water is life water, and it tested around neutral. Why? If you look at the label, the water was purified, the minerals were added, which most likely brought it back up to neutral. Then we have the bottled alkaline waters. This one is Essentia. They normally add alkali buffers to make it the desired pH. The sports drink and the soda have a lower pH, probably in the range of 2 to 3. This is largely due to the different acids found in sports drinks and sodas, such as citric acid and phosphoric acid. If the drink is carbonated, that will also result in a lower pH. So remember this when you're testing carbonated or sparkling waters, like Pellegrino, which is what this one is. This is tap water, and it tests higher than neutral, which is more than likely due to the lye added to the city water. This water was made by an ionizer, so the high pH is due to the higher hydroxide content because of electrolysis, which converts H+ acid to hydrogen gas, H2. Next, I'm going to show you the differences between pH and alkalinity. As I said in the video about this, alkalinity is the ability to buffer acid. So a common demonstration people use to show how acidic soda is to pour a little in each drink. So let's do that. Now, obviously, this example shows the soda's acidity. But even more so, this example shows these substances lack alkalinity. This means that when these waters were presented with the acid from the soda, they were not able to resist it or buffer it, resulting in a lower pH. This is not a bad thing. This means the body can change their pH to anything it wants it to be, to make it beneficial. Remember, there is a difference between pH and alkalinity. For example, baking soda has a pH of 8.1 and is a strong buffer, whereas ionized water can go up to a pH of 12, but is a weak buffer. There's a couple misconceptions about alkaline water, particularly from an ionizer, that can be debunked by this simple demonstration. Here I have 4 ounces of soda and a glass of alkaline ionized water. I'll add the pH drops so you can see what the pH is. One misconception is that alkaline water, like this kind, can alkalize your body, thus making you more healthy. The other misconception that comes from the other side of the spectrum is that this kind of alkaline water can neutralize your stomach acid, causing digestive problems. Now, I can pour this glass of alkaline water into this 4 ounces of soda, and the pH is not moved. So to address claim number 1, the buffering capacity of this water is obviously weak, and the pH can easily be changed. In regard to claim number 2, This test makes it clear pouring high pH water into something this acidic hardly affects its pH. And considering that the pH of your stomach acid is even more acidic than the soda, it's safe to say that your stomach acid is going to be less affected by drinking high pH alkaline water. Remember, this is only if you're using alkaline water made by electrolysis. Alkaline water made with baking soda will have a much higher buffering capacity and will be able to resist the pH change a lot better. Now we're going to talk about this misnomer that's floating out there about ionized water. The word is alkalize. Some even spell it like this to distinguish from its correct spelling. Either way, the word means the same thing, which is to make a substance alkaline. So is ionized water alkalized? Absolutely. Because it usually takes water that's not originally alkaline and raises its pH. But there's more to that story. So here I have 4 cups, 2 with soda and 2 with slightly acidic water. Let's check their pH. Now let's check what happens when I put a little ammonia in the acidic water. How about in the soda? Now let's try putting some baking soda in the acidic water. Now what about in the soda? Boom! These substances are now alkalized. Would you like some baking soda? The purpose of these demonstrations was to equip you with the tools to know what you're seeing with this kind of presentation. Then you won't be fooled by the tricks, but prepared with the truth. And that was your H2 Minute Experiment experience. Please support us on Patreon if you want more videos.